Hello, students. So this is a recap of today's lesson. Today's lesson was writing systems of equations. We're just learning how to write equations with two variables. You learned how to do that a little bit in 8th grade. Here are just 5 types of popular equations that I've noticed throughout the years. They come up again and again. So if we get good at these, plus add to what we learned in 8th grade, we'll be good to go. We're not solving today. We are just learning how to write them when we see them. So type number 1, once again, is the money, money, money equation. And the reason it's called that is because you can circle money 3 times in this type of a word problem. Money, money, money. So the first thing we want to do is assign our variables. We're going to be working mainly with X and Y because we want to use our solving strategies tomorrow. So we want to get used to working with X and Y today. So X, we're going to have X represent one of our variables and Y represent the other. So let's read the problem. A large family is going to the movies. Child tickets cost $2.50 each. Adult tickets cost $4.50 each. So my 2 variables, my 2 types of tickets that I'm working with are child tickets and adult tickets. Okay? So let X equal child tickets and let Y equal adult tickets. Now remember, this is not the price of those tickets because we know the price already. We know it's $2.50 for a child ticket. What we don't know is how many child tickets were bought. We don't know how many adult tickets were bought. We know some combination of these 2, that's why it's sometimes called a linear combination. Some combination of these 2 added up to $42.50. We just don't know how many of each were bought. So this is number of. Okay? Now, number of child tickets, number of adult tickets, let's get to writing. So we are adding up the totals here. This is an addition problem. $2.50 per child ticket plus $4.50 per adult ticket equals $42.50 spent. This is how we write a money, money, money equation. One of the most common mistakes is to get so excited about the money, money, money that you forget to put your variables in there. Don't forget to attach the correct amount of money to the correct variable. So $2.50 goes with child tickets, so $2.50 needs to be next to my X because that's what we said X represented, child tickets. Is it wrong if you use different variables? If I say let X equal adult tickets and Y equal child tickets, is it wrong? Absolutely not. That's why you have to tell me at the beginning which variables you assigned to which concept. Okay, type number 2, total number. It's easy to recognize a total number equation for a couple different reasons. First, generally it tells you you're working with a total. It at least says total, if not total number directly. And another giveaway is that there's only one actual number to work with. How do you write a whole equation with 2 variables and only one actual number? It's probably a total number equation. Okay, so once again, we're going to assign our variables. Let's read the problem so we know what 2 concepts we're working with. The total number of quarters and nickels is 25. So what 2 concepts are we working with? Quarters and nickels. These are the 2 quantities we're working with. So let's just assign one. Let X equals quarters and let Y equal nickels. Now, the easiest equation you'll ever write is a total number equation. How do you do it? You add the 2 variables you just assigned, and you put the total after the equal sign. That's as easy as it gets. That is how to write a total number equation. Okay? If I said the total number of cats and dogs in my neighborhood is 39, it would be X plus Y equals 39. Very easy. Easiest equation you'll ever write. Next, the balancing type. This is one of the more challenging, but we're going to draw a picture, and that way it'll help us to get over that challenge. So, for example, 3, there are 3 times as many dogs as cats. 3 times as many dogs as cats. If you see as many as or half as many, it's generally making a comparison between the two quantities. You're probably working with a balancing equation. I like to draw a picture. So we're working with 3 times as many dogs as cats. So let's make a pile of dogs and a pile of cats. Here we go. This is artwork here. My dog pile needs to be bigger than my cat pile, so pile of dogs. Little bitty pile of cats. I'm exaggerating because the only thing I need to see is which one's bigger. Okay, so I see as many as, I'm like, it's gonna be balancing. And then I ask myself, which pile is bigger, dogs or cats? Draw my picture. Now the next question you ask is, how do I make them equal? I'm trying to write an equation. I'm trying to get an equal sign in the middle here, but what do I have to do to make them equal? Well, the dog pile is larger by a factor of 3. It's 3 times bigger. So to make them equal, what if I just make the cat pile 3 times bigger? Times it by 3. Now they're equal. After you do that, you're ready to assign variables. Okay, we generally want our equation to be solved for y. So that's how we're going to leave it. It's not wrong. If you make the x equal dogs, it's not wrong, but generally it gives you more options if you're solving for y, because now you can solve by graphing. And we'll see that in tomorrow's lesson when we get ready to solve. But for now, if you have a preference to solve for x or y, generally go ahead and solve it for y. Okay, so that is how we do a balancing equation. Next, let's do a translation equation. Translation is just translating math language into math symbols. It's the same as if I'm translating Spanish to English, okay? It can't be a direct translation, just like from Spanish to English, we say things a little bit differently, but you start there. You start by directly translating, and then you've got to add your own flair at the end. You have to rearrange some stuff at the end to make it make sense. But first, let's go to direct translation. The sum. Sum means add. Twice a number. Twice a number. How many times is twice? 2 times, right? And we know that in math, when it says a number, that we're going to use a variable. So 2 times a variable. Okay, and 8. 8 is already a number. We got that, okay. Is equal to 3 less. We know that means -3 or -3 when we see 3 less. And 4 times that same number. 4 times that same number, we used a variable of x. Let's use it again. And now we've done our direct translation. Now you're going to come back and make sure it makes sense. You have to rearrange a couple things. You're never going to rearrange the equal sign. You're just going to rearrange this to make it a little more sense, and then the right side. So the sum of this and this. How do I write that? I just have to do 2x plus 8. The sum of 2x and 8 is 2x plus 8. Copy down your equal sign. 3 less than this guy, 3 less than 4x is 4x minus 3. And now you've translated it and you've rearranged. That is how we do a translation equation. Type number 5 is the formula type. The formula type is generally going to make you have to look up a formula to use. Okay, so we're going to read the problem. The total perimeter of a rectangle is 20. The total perimeter of a rectangle is 20. So perimeter of a rectangle is a formula that I can look up myself. I can Google it. I can use a textbook. I can use my cheat sheet in our notebook. Okay. The perimeter of a rectangle formula is 2L plus 2W, where L stands for length and W stands for width. So these are my 2 my two variables, L and W. Okay, so we want to make sure we've got X and Y in there. So let X equals length, for example, and let Y equal width. We're going to make one little substitution as well because we know the perimeter. We don't have to leave the P in there. We know that the perimeter is 20. So I'm going to put the 20 in for P. So now we're going to rewrite this with our brand new variables and a 20 subbed in for P. And we're going to make sure we're writing that in standard form. So here we go. 2x plus 2, what do we want for W? We want it to be Y, okay, equals a grand total of 20. And now we are in standard form. That is a linear equation in standard form, ready to do whatever we need to do with it. So that is a review of my 5 special types of equations that keep coming up again and again.